Let's solve a physics problem involving a rock falling from a cliff and the time it takes to hear the sound when it hits the water. Here's our problem. A rock is dropped from a sea cliff, and the sound of it striking the ocean is heard 3.4 seconds later. If the speed of sound is 340 meters per second, how high is the cliff? Let's draw a diagram to understand what's happening. Here's our cliff, and at the top we have our rock that will drop. And here's the water at the bottom. The height of the cliff, which we'll call h, is what we're trying to find. This problem involves two separate motions. First, the rock falls down, which takes some time t1. Then, the sound travels back up to the top, which takes time t2. And we know their sum equals 3.4 seconds. Let's look at each part separately. For the falling rock, we can use the equation h equals 1/2 gt1 squared, where g is 9.8 meters per second squared. For the sound traveling up, we use distance equals rate times time. So h equals v times t2, where v is 340 meters per second. From the sound equation, we can solve for t2. t2 equals h over v. Now we can substitute this into our total time equation. t1 plus h over 340 equals 3.4. We can also substitute the expression for h from the falling equation. H equals 1/2 times 9.8 times t1 squared. This gives us t1 plus 1/2 times 9.8 times t1 squared over 340 equals 3.4. This is a quadratic equation. After solving it, we get t1 equals approximately 3.21 seconds. Then we can plug this back into our equation for h to find the height. H equals 1/2 times 9.8 times 3.21 squared. And our final answer is that the cliff is approximately 50.5 meters high.